results showing that sludge was quite not very efficient. However, by developing some combination, we double efficiency of conversion sludge into the. Now we have 60 hectares of plantation. This is a big sewage treatment plant in Łódź, and all the green area are 60-hectare bioenergy plantation when sludge is converted into bioenergy. And on the beginning was just 1 ton from hectare. Now we came to 10 tons per hectare. We developed mathematical model to optimize the process. And this is model for decision support system. It means decision maker don't need to understand every process which has to be considered. This is hidden in the model. He has only given parameter and can play here and immediately see reaction of the system and economical efficiency. So ecohydrology has to be translated to decision makers by decision support models like this. And another story is necessary to use foresight, because river basin is big organism and every action has to be long-term plan, and foresight is methodology not only forecast the future but the management, but rather creation of future, desired future. And this is methodology invented by American Corps of Engineers and now is implemented in many, let's say, long-term strategic planning by World Bank and other sort of institution, and also this type of the, let's say, enterprise has to be equal to purpose. And obviously now is lots of interesting story which you know in developed here in coastal zone by team Professor Chicharo. Another is Center Ecohydrology was just opened in Indonesia for Southeast Asia, and us really very nicely progressing with different methodology of developing of purification systems. And the Ethiopian program has many challenges. One of the interesting solutions, I think, is just when we were invited to the area where education of sustainable agriculture was done, and there was a small lake which already was impossible to use water resources because water was toxic. When we analyzed, it appeared that dioxin concentration was very high because stream coming from the village probably was transporting lots of dioxin we were not using. So we developed the system, the filtration down. Why filtration? Because 3 processes. Erosion upstream was really filling up the lake. This whole bay is filled up with sediments, already wetland was developed here. Second, cows were providing eutrophication, already some toxic blobs starts to appear, and third process, dioxins. So it's necessary to stop these 3 processes, and we built a dam, which was first developed, used the biodegradable geofibers to stop erosion. And second, we built a dam to make sedimentation mineral matter, because certain fraction of dioxin is connected with mineral matter. And next, on special, because dam is built on gravel bed, so it's forcing infiltration of water to the all green area. And in this moment, the biological system is trapping more dioxin. During 1 year, we discover a reduction of dioxin 10 times in the lake because this system. And third element, what we know already about cows, we organize the drinking place on the bank. So the manure is collected here, digested, and used for fertilization to show the farmers that it's better to make an effort and put the water to drinking place, not in the stream, put the cows to the stream, because they provide very important fertilizer, and obviously this which are fertilized, plants are 3 times higher than those on it. Because in this center, 30,000 farmers was trained during the 3 years. So I think it's proper place to disseminate some solution. And during already when this was constructed, we had already postulated some other villages they won't have such things to do. Finally, we're at university, so how we have to think about teaching the people, the generation, which will be very complex. I think now universities are focusing to a great extent on providing information, understanding relations, but not enough in understanding processes and pattern knowledge. And technical university, information and over-jumping the knowledge and trying to generate wisdom, ability to develop technology. So I think it's necessary in university we must make a good balance between all three components, and in technical university integrating different sciences, and that's for sure will be much more, let's say, stimulating the, creating the young people who are in great potential to get good job. And finally, in environmental science, now we are teaching the narrow specialist, and every the same high diversified broad background, but next we have a specialized. And next specialist, for example, is the same. So they are sitting in 2 towers and no way to communicate. So now probably we have to, after specialization stage, go further and try to give a chance to communicate, to understand all the specialists, and in this moment find really sustainable solutions. And obviously concerning the water, I would like to show the priorities, fifth phase, and fifth time will have a similar topic as this lecture, and let's try to answer the question, one, why in Anthropocene era we need transdisciplinary problem solving environmental science, such like hydrology, because we have to reverse process of getting dry, polluted and nutrient depleted. And because in a world which is approaching carrying capacity, relation between society, water, environment become highly complex and might lead to the conflicts. And that is why we need such transdisciplinary science background for reversing degradation and enhancing carrying capacity. I think always we have to answer the question if we want to live in such techno garden or in garden. But I think our students should create something between. Thank you for your attention.
Professor, for this brilliant lecture. I want to thank everybody for your attention, and also people that were assisting through the web. We will continue this kind of lectures further on. For now, if you have any question, Professor, please. It was very interesting because it allowed to show that ecology is applied in different regions for different aspects, from the urban to the coastal, from the molecular to the biodiversity aspect, so from the entire catchment area. So I think it's a very broad science. Also that it's transdisciplinary, so it links with different aspects and different sciences that we need to put together. And so this is a brilliant theory that we need to develop in terms of solving problems for future. I have one question for you, is that we are in this process of climate change, and everybody is talking about that. And ecology deals with water and deals with biota. But hydrological cycle will change, of course, due to climate change. So my question is, if can ecology be a sustainable solution even in terms of the changes that are expected, predicted for climate change?
Yes, I read it this morning, sir, that glass always half empty or half full. It means climate change is giving some opportunities, like acceleration of mineralization process, which is key self-purification of river. But on the other hand, and that's also absorbing capacity of plants is increasing, so we can more efficiently use phytotechnologies for let's say, some purification system. But on the other hand, is putting more stress on water budget, and more carefully we have to somehow regulate. Now, for example, in Ethiopia, when we calculate the budget in the Rift Valley lakes, which are drying, we just found that they just declined 1–2% of the water budget a year. It means it's a rising decline, but the reverse process is enough to put the shelter belts of tree, which will reduce speed wind and in this moment rate of evaporation, just every 400 meters, theoretically. This model has to be tested now empirically. However, it's showing that in this moment we change about 4% of water budget positive way by reducing wind speed. And in this moment we can probably reverse the process of drying the lake. However, still lots of research is needed in different parts of the world. on such process, such solutions, and that's why I think our students here will just take a challenge and will do it, and develop, and many other more brilliant even ideas.
Is there any question?
Yes, I'm quite sir. What is the approach for eco-hydrology application for those cities in third world countries where the population is quite high and there is no space to build up something like dams that you have shown in huge? So what would be the approach or the perspective to apply or implement all these eco-hydrological solutions for those problems?
Yeah, I think always if you look on some space, means you have to always look for the basin. In basin always you will find the ability to, some measures, which already examples. So I'm saying that unfortunately river basin is superorganism. Each is different. Like another antibiotic will be good for me, another for you. And the same, that's why, still I think that it's necessary to, that's why it's so important is understanding general theory of ecohydrology, because having an understanding general theory, you can adjust to local condition solution, because hierarchy of drivers is different, hierarchy of problems is different in every basin. And that's why ecohydrology is not just cookbook recipe that you can select this or this recipe and solve the problem. You must put your integrative transdisciplinary knowledge and try to, obviously you can support yourself by analogy with some solution, but it needs, some kind of really creative thinking, and I think it's best insurance for an employment for you.
In general, we have rich countries and poor countries, and essentially the rich countries do all the research and try to transfer the technology from the rich countries to the poor countries. Right? So, what do you think is the role of ecohydrology in this old model? Because ecohydrology can allow poor countries to develop new solutions, but in which extent?
Okay, in my lecture I show this system, which is a low energy system to purifying stormwater in the city. And in this moment, there's many solutions like this. I had no time to introduce another lectures with denitrification area and so on. And in general, a synonym of ecohydrology in UNESCO terminology is low cost, high technology. Because it is low energy, low cost and high tech, because high advanced knowledge has to be used to construct this and adjust to the local conditions. And that's why I think it's especially important for countries which are not really very, let's say, rich. However, and additionally, as I today know, only half of the success is technology. Second half is systemic solutions which are just based on your understanding of system function.
Okay. So again, thank you very much for your time and the lecture, and thank you very much everybody for coming to the system. See you all.